Hello, this is the video showcase of Platform, the social media aggregation app for our capstone project, Mod 4. Platform is consisted of a separated front end and back end. The front end is built in TypeScript and React, and the back end is built on Rails and features a Python microservice, but is mostly written in Ruby. Platform aggregates many different content feeds into one cohesive whole. I can show that off by getting started with the Get Started button. We'll use ZFG as an example here. So this is the creator ZFG. You can see that his YouTube content is being displayed here just in order of recency. If you switch here to the Twitch app, you will see that the same creators Twitch feeds are populated by the Twitch API in exactly the same way, ordered by recency. We have an option to favorite a creator up here in the top right. You can see that if I move over here to saved creators, all of these creators are saved. And if I go ahead and unsave them, you will see that they no longer appear in our saved creators page. We also have a Twitter implementation, which I can show off here. This is the same app running locally. If I go over here to Twitter, this is just, nonsense kind of seed tweets from Mr. Beast. The biggest challenge of working on this application was definitely the interfacing of front end and back end. It was really challenging and fun to just sort of understand how best to work together and how to organize the tasks in a way that made sense. Just trying to make sure that no one has blockers, communicating through blockers that we did encounter, and just kind of really trying to be empathetic to make the work experience pleasant and productive for everybody.
Elevating quality assurance across platforms with Cypress testing. In our project, Cypress serves to ensure that every feature we deploy meets the highest standards of functionality and performance. With its intuitive syntax and powerful capabilities, we've seamlessly integrated Cypress into our development workflow. Our tests in Cypress are not just validations. They're standards of quality meticulously crafted to simulate real user interactions across our application. Ranging from navigation to element interaction, Cypress effortlessly mirrors the user's experience, identifying any inconsistencies along the way. Some challenges that we faced with Cypress testing was the interactions it has with continuous integration, continuous deployment environments. Having to introduce the usage of the syntax Cypress wait due to utilizing CSS fade-in and animation on elements resulted in test failures to how quick the tests were running in the CI environment versus locally. Using CY wait withheld the test within the CI environment from immediately grabbing the element it's expecting to pause an amount of time till the fade-in animation finished, thus allowing the element to be present for the test to continue passing successfully.
Hey, this is Dana. I'm going to talk through favorite and unfavorite saved creators. So in our main app file, we have a state variable for saved creators, which is an array of all of the creators that have been saved by the user. And if you scroll down here, we have two new functions, one for favoriting a creator and one for unfavoriting a creator, which have been passed as props down into the details page, all three of those: saved creators, favorite creator, and unfavorite creator. And then over here on the details page, we have, they come in here as props, and there's a couple of things that happen on this page. So with the use effect, as the page loads, we set the creator based on whatever the creator was clicked by the user. And then the first thing we do is check if that particular creator is favorited. So we do this with this function here, and what happens is we iterate through the saved creators array, and we try to see whether the creator that we're currently viewing is contained within saved creators. If it is, then we set favorited, a new state variable, to true. And if it's not favorited, then we set favorited to false. Based on whether favorited is true or false, will dictate which button is displayed on the page. And then lastly, on click of either of those buttons, if it's already a favorited creator, it will unfavorite that creator and then set favorited to false. Or else, if it's not favorited, it will favorite it and set favorited to true.
One of the main features in this iteration is the implementation of the React testing library. Simply typing in npm run test you can run all the different React tests that we have for each of our components all at the same time. The reason why we chose to have the React testing library is that it allows you to test a single individual component without loading the entire application. This saves in time for testing as well as making sure that each individual component is operating and functioning as expected. By simply pressing A here, you can run every single test that we have. Of the total test suites, we have 9, one for each of our components. And of the total tests, all 32 are passing right now.
As part of our backend stretch tech, we decided to dive into the interesting world of caching. We wanted to implement caching because it's a useful skill to be familiar with and allows for faster response times and a better user experience. First, we needed to identify the best place to implement caching, so we integrated an observability tool called Honeycomb. Here's our Honeycomb page. It gives you stats on responses and requests that have been made to your app. Using this, we figured out that our creators, controllers, show, and the index were the longest response times. So we decided to implement caching using those API calls. Go to the code here. Essentially, you just need to enable it in your development and production environment folders right here using built-in Rails functionality. It's going to store it in the cache here. And then we went to our Twitch and YouTube facades. This is the original method that is called here, depending on whether or not it's been called in the last hour. So you basically call rails.cache fetch. It checks to see if something's been cached for the amount of time. If it has, then it uses that. If not, it'll make the original call. And you can see in Postman, so we'll change it to a new one. Send a request here. It's about 982 milliseconds. Send another one, it's down to 50, down to 16. So dramatically reducing it by about 90%. It's pretty sweet.
This is the Twitter scraper that I made. Unfortunately, I was not able to get the database up and running. Well, I did on the local side, but I could not put it up on Heroku because it kept crashing on me and I couldn't fix it. But this is the web scraper that we have where you can input any Twitter ID. This is the Mr. Beast ID. And when you press run, then it will scrape their Twitter webpage. It takes a second. With this, you will have the ID of the tweet ID, because every tweet has an ID and when it was created. And using this ID and the handle, you are able to create the front end Twitter embeds that you see in the front end. Another thing that I want to display is just a funny communication error that we had where the front end was trying to couldn't delete the follow because they were keep trying to input the creator ID instead of the follow ID, and it took like a long time to actually figure out what the disconnect between what the front end people were trying to do and how the back end was operating. And this is just something that we had to do. Not really a big deal. It didn't take that long to fix, but it was just a funny little communication error that we ended up sorting out.